Hey, Poema, I have your test here, so I'm going to go over the questions that you missed. It might be kind of a long video, so just kind of bear with me as we go through this. So the first question asks, what's the value of x in the product of powers below? So remember that when you are multiplying like bases, you should be adding exponents. So 9 plus x would equal 2. You chose 7. 9 plus 7 is actually 16. We want -7. We actually could solve this like a one-step equation and find that x should be -7. Question 3 asks, what's the value of k in the product of powers below? So we're getting 10 to the -3rd as our answer. So we have 10 to the -3rd times, remember, 10 to the 1st times 10 to the k, and it needs to equal 10 to the -3rd. Well, that's what this is, which means that these two pieces have to cancel out. So if this is 1, then that has to be a positive 1. Or again, you can set up an equation. -3 plus 1 plus k has to equal -3. So if we combine these two like terms, -2 plus k equals -3. Adding 2 to both sides, and we get that k equals -1. Which expression has twice the value of this? So when we talk about twice the value, when you say twice anything, it means you're just multiplying by 2. So this is 2 to the 5th. If we want twice that, we're going to multiply it by another 2, right? Twice something means you're just doubling it or multiplying it by 2 one time. So that has a 1, an exponent of 1, so it would be 2 to the 6th because you would add the exponents together. Which expression can be simplified as 1 over n to the 18th. So we need something that's going to give us a -18, right? N to the -18th is what can then be simplified as 1 over n to the 18th. The answer you chose gives us +18. The answer choice down here, n to the -3rd to the 6th, we do multiply these powers, so that gives us -18. So remember that when we write numbers in scientific notation, this factor out in front has to be between 1 and 10. So 89.12 is too big. The decimal needs to be moved in between the 8 and the 9. And since we're making that number smaller, we're moving that decimal one more time. We need to compensate by adding another 10 onto the back of that. So 10 to the 6th instead of 10 to the 5th. But the correct answer is that she's not correct. It's not written in proper scientific notation. Again, because that front digit she's got too big. She didn't move the decimal enough times. So it should have been 1, 2, 3, 4, 5, 6. Which expression is equivalent? We are multiplying when we have power to a power. So here's the difference. Q to the 6th times q to the 2nd. Oops. Means I have 6 q's being multiplied together times 2 more q's being multiplied together. There's where you're adding. But when you have a power raised to a power, it means we have 2 q to the 6's, right? This is q to the 6th times q to the 6th. Now if we add again, that's q to the 12th. Or here, if we can just take the rule here that says to multiply. So the correct answer is q to the 12th. In this one, because all the 4's are not negative, we would not use a parentheses, so it's not -4 times -4 times -4 8 times. Notice only the first term is negative. So this is really 4 to the 8th, but since that front term is negative, we just put the negative out in front. You could also write it like this. Could have 4 to the 8th with a negative out in front. But your answer choice here shows that all of the 4's are negative, all 8 of them, and that is not the case. Question 12 wants us to evaluate. K is -2 and A is 5. So 3 squared, 5 to the -2nd over 3, 5 to the negative first, and it's all being raised to the negative second because k is negative 2. So let's do some simplifying. I'm going to go ahead and you can do two things here. You can do your subtraction inside because we have division of like bases and then raise everything to the negative second power, or you can raise everything to the negative second power, all four pieces in here, both 3's and both 5's, and then simplify. I think I'm going to do it that way. So remember when you have a power raised to a power, everything is getting that negative 2 power. So we're multiplying 3 to the negative fourth, 5 to the fourth, over 3 to the negative second, 5 to the second. So now our rules tell us to subtract negative 4 minus negative 2 is like negative 4 plus 2. So that's to the negative second. And now we just do 4 minus 2, 5 to the second. That negative exponent has to be simplified by moving it down into the denominator. So we end up with 5 squared over 3 squared, which is 25 over 9. Question 16 is again, what's the best estimate? So the reason why your answer doesn't work again is because that is not proper scientific notation. 60 is too big. That number has to be between 1 and 10. So automatically you're ruling out both of those answers. This is about 6. This is about 10. It would be 60. If we add our exponents, we get the negative 5. But then we have to fix this by moving the decimal in one time, right? We're dividing by 10. So I have to compensate by showing an additional 10 that we're multiplying by, which means we're adding 1 to this exponent of negative 5. Question 19, Eli claims that the product of 6 to the 5th and 5 to the negative third is 6 squared. Explains whether Eli is correct. Well, he's not correct because the bases aren't the same. Oh, yeah, that's what the right choice says. So the only time that you can add exponents is when your bases are the same. So it would have to be 6 to the 5th times 6 to the negative third. Then we would get 6 to the second. But because this base is a 5 and this base is a 6, we can't add those exponents together and simplify the expression. We're going to use the steps below to evaluate the expression. What step did she make her first error? Oh, of course, all the way down in step 4. Okay, so let's try to figure out what she did. First, she plugged everything in. So negative 1 went in for x, 2 went in for y. So that all looks good. Then she simplifies the parentheses. I'm going to have to scroll a little bit first. So we know step 1's correct, so I don't have to see the problem anymore. Simplified the parentheses. So she cleaned up things inside. So anything that had a negative exponent, you can see this had a negative exponent, this has a negative exponent, and that has a negative exponent. So the two pieces on top move into the bottom, and the piece in the bottom moves back up top. So that's what happened here. Then what happened? We combined those negative 1's and got negative 1 to the 7th. 4 plus 3 is 7. And they combined all of the 2's. So let's see, we did 4 minus 2. Okay, this is weird. They did 4 minus 2 to get that one, and they left this one in the bottom. Not sure why. Now everything's getting the negative third power. So 2 times negative 3 is negative 6. 2 to the first, so that's 1 times negative 3, there's negative 3, and 7 times negative 3 is negative 21. Then using reciprocals, we should be fixing, oh yeah, so we move this one down into the bottom, that's how we get this one positive, but these were both negative in the denominator, which means they actually should move up to the numerator, and I forget her name, Rena, all she did was just make them positive. You can't just make exponents positive. In order to do that, you have to either move it into the denominator or move it up into the numerator, the opposite position of where it was. So it should have looked like 2 to the third times -1 to the 21st, and then the 2 to the 6th would have been in the bottom. So yeah, that error was all the way down in step 4. Not quite how I would have solved it. Obviously I'd like to fill everything in, substitute everything in. I like to go ahead and apply that -3 exponent right away, because I feel like then you're moving stuff twice, which is what you can see happening here. Here they adjusted things to fix the negative exponents from here, but then they had to do it again here, and you don't want to do that twice. 25, what's the value written in standard form? So when we're dividing scientific notation, you can divide those two numbers and you can subtract the exponents. So 6.6 divided by 3.3 is 2 times 10 to the, we're doing -2 minus -4, so that's like adding a positive. So we get 2 times 10 to the second power. Remember, in the number 2, the decimal would be here. That tells us we're multiplying by 10 twice, so that's how you get 200. So I know that was a lot. I hope a lot of that makes sense. You said you felt pretty confident about the unit review. So hopefully you do well on the next test attempt. If you have any questions or don't pass again, please let me know.